How many of you knows actually what microservice is? And well, it's about 40%. And how many knows what the chatbot is? Good. So it's not going to be really technical talk. It's more like conceptual, and I'll try to show you how I see the future of the architecture in general, and how I think we're going to design systems in 5 years, in 10 years, maybe in 20 years. And this is all based on my vision and my experience. So I do use these chatbots in my practical projects, and I do use microservices. And I combine them together, and I implement these microservices as chatbots. And it works. And I want to share it with you and try to encourage you to think that way. And maybe this is going to be our future. I believe it's going to be. But let's see. So I'll show you six steps, which our current architecture is moving forward from the monolithic architecture, where everything is built in one big thing, to the architecture which will look really heterogeneous in the future. It doesn't look right now, but these 3 steps on the right, this is how I see the future. The first 3 steps is what we have right now. It's already happening. We have it in practice. We have it in books. We have it in practical projects. But the last 3 things is what I'm going to explain to you and promise you that this is going to happen. It's going to be about 35 minutes, probably less. Again, it's not going to be too technical. It's more about high-level architecture and the vision. So I'll show you 6 diagrams. So all of these 6 steps will be 6 diagrams, but they're not going to be complex. Still UML, but not complex. So the first step, this is how we designed systems for many years before. This is monolithic architecture. So we have a big piece, which is called the system, or a web system, for example, or mostly I'm talking about web systems. It's a big monolithic piece of code which contains inside some modules, module A, module B, whatever. There are some modules, some components inside, and they communicate to each other basically through the code. So they call each other through just basically method calls or in-code calls. So there's no network connection between them. They're basically Java or not Java or .NET, some pieces of code which communicate to each other through inter-method calls, or what do you call it, like the Java calls, basically. There are many benefits of this architecture. It existed and then we have a client, obviously. On the left side, you have a client who is talking to the system through HTTP interface or whatever, basically the web client, the user sitting in front of the browser. And there are many benefits of this architecture. First of all, it's easy to build. When we start building it, we just create all together. Just one programmer controls this module A, module B. There is it's really not difficult to connect them, because if you want to use something from module B, you just basically call it. You have the documentation for it. You have it is explained. You can look how it works. It all stays together in your IDE, in the place where you develop the stuff. So also, the mistakes you make are really not visible. So everything is under your control. So it's inside your big monolithic piece of software, and you're responsible for everything. Not anybody cannot see what's going on if they're outside of your team, for example. So it all belongs to you. You control this piece of code. And it's kind of good for job security, this architecture. So you build it, you design that, you own this code, and you're going to stay in this job for as long as this piece of code is alive. So it's pretty good. This is how it was before. But there are problems. There are pros and cons. So the problems here is, first of all, we start seeing problem when it starts growing big. So this is perfect for the small system. When the system starts to grow big, it's kind of difficult to maintain it, because all these connections between module A and module B, they become less and less visible with time, and modules start to how to say it, to merge, yeah, exactly. And it's not anymore a module A and module B. It's just a piece of code which interconnects to each other. Sometimes we can even see spaghetti code. When the module A becomes module B and the module B becomes module A, we don't know anymore which module it is. We just have a big monolithic system which, with some lines of code, they interconnect to each other and they merge. So the concepts, that was initially the separation of concepts. One module does something, another one does something else, and then eventually these concepts, they start to merge, and we have one big, huge monolithic concept of the product. So it's really unmaintainable. And it's difficult to reuse. So it's difficult to reuse, and in the future, it's difficult to come in and say, we want the functionality which you guys designed 3 years ago, and we want to get that piece of functionality and use it somewhere else. It's not really possible, because it's all monolithic and all together, assembled together. And if you want to take the piece of this functionality, we can, in the best case, we can give you some piece of code which you can put in your stuff and then reuse it somehow. But you cannot just call us and use a piece of functionality from us. So that's a problem for reusability. And like I said, the architecture becomes unclear. Not just the code, not just these modules merge into each other, but the architecture in general becomes unclear. And in the end, it's just one big piece of code which just works or doesn't. That's the first step. That's how it was. That's how it works in most cases. And now we have the microservices. That's the idea which is kind of fresh, and we start using this idea, and it's coming to the market for the last few years. So we break down this into microservices, and we still have this system. We still have the system, but now it's not so solid. It's not so monolithic. We break these modules down into standalone pieces, and they start to communicate between each other through HTTP API calls. So the module A now, in order to do something, to ask the module B to do something, it's not enough. This module cannot just call the Java method, cannot just call the Java class. It has to make the HTTP call through the API, which is more formal. So it becomes way more difficult for this microservice to merge with this microservice, because they basically stay on different machines sometimes. They are designed in most cases by different groups of programmers, so they cannot merge anymore. So it's perfect for the isolation and perfect for maintainability. So now as the system becomes way more maintainable and way more stable, and the architecture will be way more visible for the future, because we're not able to create a chaos and create a mess from this architecture, because they are separate. And also another benefit of this is that we have smaller pieces. So the software becomes smaller. In the previous case, when the monolithic architecture, it was a big one, huge piece of software with millions of lines of code, like we've heard in the previous presentation. The question was about, what do I do if I have 1,000,000 lines of code? In this case, the 1,000,000 lines of code is really a bad example of a badly designed software. If you have 1,000,000 lines of code, there's a big problem in the first place. In this case, it's not really typical to see a microservice with a 1,000,000 lines of code. It's usually like a few thousand lines of code, maybe a little bit more, because these pieces it's better to design them to be small. So they organically, naturally small, these microservices, which is good for maintainability. The smaller the piece, the more maintainable it is. And it's easy to deploy. That's the last thing which is good in this architecture. It's easy to deploy. You can deploy them separately. You don't need to deploy the whole big monolithic system. The deployment is in general a problem. And if you deploy the whole big system to production, then it will take time. You will have more risks. You will have more problems. You need to configure it properly. So it's way more difficult comparing to deployment separately of small microservices. This one goes to one server, another one goes to another server. That's the architecture which becomes composable. So the previous one was monolithic. This one is more composable. We can compose it from pieces now, and we can reuse them. And that's my next step. So about the reusability, step number 3. So we are getting to the actual reusability. We start using these services, not from, if you compare the previous slide, here we have the client who is talking to microservice A, and then this microservice is using microservice B to do something for the client. But still, the client is talking to one entry point, like with the monolithic system. There's still one entry point where the client connects, and then it's our job inside how to talk to each other and how to combine us together to deliver the service to the client. If we become reusable, then the client is able to talk to all possible microservices. So we are making our architecture more open, and we let the client reuse us in the way the client wants. So it's not anymore about programmers who make microservices for programmers, but about us making these services available to everybody else outside of the system. And that's a really big achievement on the microservice domain, on this territory. So they're not anymore pieces for programmers and made for programmers and being used by programmers through the API. But that's the stuff which we make public, and we announce this API. We make it visible for everybody. We make the documentation. We publish it somehow, even though they're internal. Maybe these microservices are internal for the enterprise. But we document them. We make them visible for other programmers, because now the clients are also programmers, and they are not just users, but they are also technical people who may reuse our stuff and may use the functionality which was implemented originally for the service A. But then in the future, the client may say that we need it for something else. We need it for some different purposes. Maybe we are building another system which can reuse the stuff you built a few years ago. So now we can just use it. All we need from you is just the API properly documented. So what's the benefits here? What do we gain by making it available? By making our microservices available to everybody, not to just programmers, not to just the original client, but to all clients. First of all, it's cost optimization. So we are actually saving money on remaking stuff. So if we make the microservice, for example, let's say it's a CRM system, not the CRM, but some e-commerce system, and we have the payment module, which is able to process transactions. So we make this transaction processing service available to everybody, and then they can reuse it without spending any more time to building anything from scratch. So this is cost optimization. So we are making services available like libraries, but they are hosted libraries now, not just libraries which people need to download, but they are hosted stuff. So that's cost optimization. Another thing which is good is we will definitely have higher quality demands, because we cannot anymore create this. If I'm a programmer here, I cannot just create this microservice just the way I want it, with the quality, the low quality, and not really paying attention to documentation, not really paying attention to the way I design the API. It's going to be not really easy for me to do that, because I will have so many clients around me complaining about that. So I will have to make it higher quality, because there will be many more users, comparing the situation where there's a monolithic system, or even it's a microservice which is for one client. If I have more clients, inevitably my quality will go up, because I will have more complaints, I will have more bug reports, I will have more people asking me to make it high quality. So that's why the quality of these microservices will go up, inevitably. That will happen, which is good for everybody. And together with the quality comes the better documentation. So I will, again, inevitably document it better and make it, more easier to understand for everybody. So that's what's happening, and I would call it reusable. So this is the situation where the microservices are reusable. This is what we have now. And now what I think will happen in the future. That's everything I just explained is just a preamble. This is what we have now, and probably you know it better than me, how it works. But now I see 3 new steps which will happen in the future, which is happening already in a few of my projects, and I think it's going to happen. Step number 1, it's number 4 actually, is when these guys become decoupled. So instead of talking to each other through the APIs, they will talk through the communication hub. So we'll have 1 microservice, 2 microservices, many microservices, and instead of declaring the API here, they will have some communication hub. For example, let's say Slack, for example, or I don't know, Facebook Messenger, or the IRC. So some place where these microservices can connect, and they can post their requests, and they can get some responses from other microservices. So in traditional design, if I need something from this guy, I just directly connect to this guy, and I'm getting the data from there, and I'm getting the response back. In that design, which is decoupled, I connect to some hub, to communication place, to communication platform, and I post a request, like I need this payment to be processed. I need this customer A to get I need somebody to take $5 from the credit card of the customer A, and give me the answer when it's ready. So instead of connecting to this payment microservice and sending the API call, through the RESTful API, and saying, how about you process the payment for me, and staying online and waiting for the result, or maybe connecting again and again, I don't know who is this microservice in general. I connect to Communication Hub, I post a request, maybe a text, maybe a JSON, maybe an XML, and then in a few seconds, or maybe microseconds, or maybe minutes, I get a response over there in this communication chat. And the answer is, yes, we just took $5 from the client. So now our microservices become chatbots. So they are able to talk to each other using some language, some JSON language or XML language, or just plain text language. So we turn microservices into chatbots, and this gives us a lot of advantages comparing to the previous architecture when they have to talk to each other. So what are the advantages? Is it clear how it's going to work technically or not? Okay, probably, yeah. What's the question?
I do see this as a service bus or a queue,
Yeah.
or
Let's call it service bus or a queue, but a little bit later. But let's say, yeah, for now it's like a service bus or a queue or like a message queue, whatever.
Event bus.
Event bus. You call, yeah, whatever you call it, event bus. Let's call it event bus for now. If this is the name which is clearer. But you got the idea. This is something where I can drop my request and then come back and say, do you have some answers for me? Do you have some responses to me? Yes, the response is waiting for me over there.
But is it polling or is it really true?
It depends. You can be polling, you can be waiting for, but in general, I would suggest, further I'll explain why, I would suggest instead of polling, just basically coming back and asking, do you have something new for me? Let's call it polling, yeah. So you just jump into the chat, like in Slack, for example. You jump in, or a Facebook Messenger, and you basically see what's new for you. So this is like 5 messages unread. So I've seen everything before, but there's 5 new messages, and this is what my previous message. And then after I posted that message, I have 5 more messages, so I can read them. But I'm talking not about a person, not about a human, but a computer. So it's a microservice who connects to, let's say, Facebook Messenger. Maybe that's an extreme case, but Slack is a better example. The microservice connects to the Slack and then keeps talking to each other. So we understand technically, right, how it's going to work. Okay, so what benefits do we have here? The biggest benefit is that the service becomes a client instead of being a server. So in the previous diagram, you can see the direction of the line. So this one is a client and this one is a server. So the client makes a request and the server is supposed to, here and here, is supposed to stay online 24/7 and answer this request. This is one design. And the design of a client is way different. So here, these guys are only clients. There we have only one server where the requests are coming in. This is the hub. To design a client is way easier than designing a server. I mean, in terms of performance, in terms of load control, in terms of scalability, in terms of data integrity, all many different questions. It's way easier to design a client who is making 1 million requests an hour than to design a server who is handling 1 million requests an hour. So by changing this, by reversing this architecture and placing and removing the server functionality from here and turning these guys into clients, we make it way easier to make them, to design them, to implement them. They are now just small, simple HTTP clients which send as many requests as they need, and they don't care about performance, scalability, whatever. If you want to make more microservices, you basically put 5 more machines and they keep sending questions to the server. So the only problem we have here is how to implement the hub, which will be able to handle 1 million requests a minute or an hour or a second. That's the only problem. And for that, we have pretty much standard solutions. We have like public hubs, we have like IRC servers or Slack or whatever, like Facebook Messenger. So we have solutions which we can get it from the market, they can be hosted, we can sometimes pay for them, and they will be able to provide us enormous scalability, and they will be able to handle as many requests as possible. So to design a client, it's way easier than designing a server. That's one huge advantage, which not only performance, not only scalability, but also another thing, which is the interface. So we don't need to make these guys, we don't need to make them, we don't need to care actually about that much about the documentation. We don't need to care about how to make this RESTful API properly designed. We don't need to care if sometimes these microservices, they have even the web interface. So we don't need to make that web interface. We're just making clients. We're just making a server-side Java software which connects to somebody, checks what's new for me, gets the response, and does something else. So it's pretty much isolated, standalone Java server-side software, which has nothing to do with being a web server and being a RESTful API and publishing this RESTful API. And we don't need really to care about making it 24/7 available. We don't need to care about stability of that stuff that much. We do want these guys to be online 24/7. But if they go down for a few minutes, it's not a big problem. Because this guy, if, for example, I want to charge $5 from the user, I post my request on the hub and say, hey, how about you charge $5 from the user and let me know when it's done. And then the answer is coming back not in half millisecond, not in half a minute, but in 2 minutes. Do we really care about that? Is it so important for the architecture? Not really. But if I connect from here to there through the RESTful API and I open HTTP request and I'm staying online waiting for the answer for 2 minutes, then it's probably going to be considered as a downtime. If this guy will say, hey, this microservice is down. I can't rely on it anymore because I'm waiting for 2 minutes already and there's no answer. But because this one is just temporarily down, maybe it's just being redeployed and we just don't have the redundancy there or whatever. It's not that reliable. It's going to be a problem. But if we decouple all these guys, if they're not coupled anymore, then the availability of them becomes of not that much of importance. That's the thing. Yeah.
Then you think about launching automatically if they do not reply 30 seconds or something, like a subscribing server.
You mean in this configuration?
Yes.
Yeah, that's possible. Yeah, you can configure it the way you want. You can configure if this one is not replying, then you basically like reboot it or restart it. It's not really important because there are no connections being already opened and waiting for you. If you're making a web server, you don't want to drop all the connections and just restart yourself. That will cause a lot of troubles for your clients. But in this case, if all the clients posted requests to you and you have a Java bug and your stuff doesn't work, you basically restart it and no harm done. Because all these guys, they don't know about that. They don't know that you were down. They don't know that you had the downtime, that for 2 minutes you were not answering anything because there was a Java bug and the microservice was completely down. Because all these two microservices, they are clients from now on. They're not servers. So even though they're still called microservices, they are chatbots, so they talk to each other being clients. This is a huge advantage. So I've implemented in this architecture, I've implemented a few microservices on my own, and my experience is about 2 years with one of them, which is quite popular. We have like about 300 active users who are like actively using it. And the service is working, sometimes it goes down, sometimes it's up, sometimes it's down, but it's really, we just know that it's really not visible for our users. So the clients who work with us, the real people, not only microservices, but real clients, people, they work with us, and they don't see our downtime that often, even though we have that downtime. We have it like every second week or maybe every month. We have something goes wrong, something with the service goes down, sometimes for a few minutes, sometimes for a few hours. But our clients, they don't see that often. Because like I'm saying, because they cannot, there is no page where I can go in and say, hey, I'm trying to log in and I can't log in. And they start tweeting and saying like, hey, this service is down. They don't see that. You know, to see that, they really need to post something for us, and then there is no response for an hour, and then they say, okay, this microservice, this chatbot, is not answering for some reason. In that case, they start complaining and saying, hey guys, something is wrong with you, and then we fix the problem. Or we find out before. We understand the problem before they understand it. So that's the architecture we use. We have 2 more steps, and then I'm done. So the step number 5, which is going to happen in the future, after we design it that way, and I think it's going to happen. We will have microservices as chatbots. Then we will make them visible. They will talk to each other, not only through the, like you said, the message hub or the event hub or event bus, but these messages they send to each other, they will become visible to normal users, to people. Not only computers, but also humans will see how microservices talk to each other. So the language between these microservices, the language these chatbots are using, will be plain English. Not JSON, not XML, not some super like computer understandable structures of data, but it's going to be just plain English. So one microservice will say, literally, how about you charge $5 from user Jeff, period. And then the next message comes in, I just tried and I got a decline from his bank, period. And then I, as a user, I log into the same hub, I jump into the same chat, and I see what's going on there. I see that the one microservice just wanted to charge Jeff for $5, and another microservice said, like, I can't do that because there was a decline from the bank. So I can see as a user, as an administrator, or just a normal user, or something like that, I can see what's going on between my microservices. I can see how they communicate, how they interact. And I'm able to interact with them as well. For example, I can post, hey, how about you explain me with more details what happened with Jeff transaction just 2 minutes ago. And then that microservice says, no problem, here's the details I just got from the bank. Boom, this is the details of the transaction. And then I say, like, how about you retry it right now? And it retries. So I'm communicating with them, not logging through the UI, not logging to their web's interface, but I'm just talking to the chat with them. And they all communicate through this chat and with me as well. That's how I see the future of microservices and chatbots. And we have it, again, we have it in practice. So we are trying to use that for about 2 years, and it really works. So we have a few microservices, and one of them is actually telling us what's going on with the machines where the stuff is being integrated. It's for continuous integration. And we have users who are talking to this service and giving commands and asking the answers and getting results. And everything is happening without the UI, without the user interface. Everything is happening on the chat channel. We're using GitHub issue tracking functionality for that. So what's the benefit here if it's visible? First of all, like I said, it's easy to monitor, so it's easy to understand what's going on. You don't actually need to, in most cases, you don't need to be an administrator to understand what's wrong with any of these services. So it's easy to monitor what's happening. It's easy to trace. It's easy to see what happened an hour ago. It's easy to see what happened a day ago, because all this conversation, it stays online forever. Like in a traditional way, when this guy connects to this guy, and then there's some bug, and then something didn't happen, and for example, the transaction was not processed, and it was declined by the bank, we need to go to the log files and see that log files, find that position, where it happened. Then we need to compare the log files from here and then from there, and see, okay, that guy made the request, and the failure happened there. So it's kind of difficult. If we put all this information in one chat room, then it's way easier. You just jump in as a user and you see how your microservices were talking to each other. So it's easy to monitor. And it's cheaper. In this case, everything is cheaper because you don't need to build the UI for these microservices. You don't need to spend time and money for making these components really attractive and visible and everything. And here's the list of, this is one of my last slides. This is the list of things these are the platforms, which just a few of them, which you can use as a platform, as a chat room where these chatbots can talk to each other. We are using GitHub issues. So in GitHub you can create, who knows what GitHub is? All right, so in GitHub you have issues, and you can open an issue, it has a number, and then in this issue you have like many messages where your people and developers and computers can talk to each other. So we are using GitHub. Slack, it's also possible. IRC is also possible. Facebook, they're just starting that. They just introduced this functionality. I'm not really thinking this is going to be a good platform for microservices, but still, that's just an example. And this is what these guys actually give us, which we don't need to implement. So when I'm designing the microservice and I want this microservice to talk to my users and to other microservices, then I don't need to implement authentication, authorization. I don't need to build a web interface. I don't need to build mobile interface, RESTful API. I don't need to be fast. I don't need to be volumeful or friendful. And I don't need to try to be lightweight. All of this stuff is given to me by GitHub. So all this functionality, I just get it for free. So when you start to develop the microservice, you have to implement all of that. You have to, if you want your microservice to have some web interface, at least something for real users, not to other microservices, but maybe some other users will be able to log in and check what's going on and maybe configure something, then you will need to implement all that. And this is what we get for free from these platforms, from this hub where these microservices talk. And the final step, and we are done. This is how it's going to look in the future. They're going to be heterogeneous. That was the strategy a long time ago, maybe 15 years ago. People thought about how to integrate complex enterprise systems in a way that this one is .NET, this one is Java, and this one is old COBOL, whatever. And they were thinking about this. The Corba standard was they introduced that time, and all the different object standards, and then they died, more or less. But I think that's what's going to be in the future in the more lightweight approach. So we will have microservices, and we will have the hub, and we will be able to integrate new microservices into the same chat. So it's not going to be only about microservices created by me, but I will create the microservice that is able to do which is able to provide some functionality. And all I do is I announce it to the world that my microservice is listening to you on Facebook, and his name is that. And then any developer in the world can just jump in, start a chat, and start using my microservice. So there is no web UI, there is no registration, there is no page for login, there is nothing like that. I just jump in, I find this guy, this microservice on Facebook or on GitHub or on some other communication channel, communication platform, and I say, hey, hello, what can you do for me? And the service immediately answers, like, I can do this stuff for you. I can work for you. I can do this, provide that for you, and probably you will pay me that and give me your credit card. So you start talking to the service. And what's going to be even further in the future, these guys will start talking to each other. So we will be able to invite a few of them to the same chat. and tell them what to do, and they will start working with each other. And this one will be implemented in Java, this one will be implemented in .NET, and that one will be implemented in PHP. And they will do completely different things. But we will be able to orchestrate their work and coordinate them just by putting them together in the chat. So that's going to be the future, I think, architecture. So the systems, they will not talk to each other through their APIs and connect to each other and know their IP addresses and open connections and send XML, JSON messages and see how it works. But they will be able just to be invited in the same chat room and start talking to each other using some maybe language, just English, plain English, maybe some more formal language, maybe the language with some pre-specified format. But they will talk to each other in the hub. That's, I think, what's going to be the future. And that's what I wanted to tell you. That's it. What do you think? Am I close? No? Yes? You don't think so? Yeah.
How do you know when it's down?
When one service is down.
Yeah.
When it's not answering, it's down.
Okay.
In our experience, that's it. So the user, or the customer, the user of the, let's say this is the client, and this guy is supposed to do something for me. So let's say I'm posting a request, or this person posting a request, do this work for me. But there's no answer for a minute, for 2 minutes, for 3 minutes. It means that the service is down. That's it. Maybe thinking. Yeah, depends on the contract, depends on the promise. So what exactly was promised? If the service promised me to answer in 5 milliseconds, or maybe, I don't know, 50 seconds, then yes. If there is no answer in 50 seconds, then no. In our case, we have this chat bot which is for continuous delivery. So you post a message and say, get my code, package it all together, and deploy it to the server. That's the service we provide. And it takes sometimes 30 minutes, 40 minutes, because it takes time. So in this case, the chatbot says, I got your request. That's the immediate answer. When you post a question and say, hey, do it for me, the immediate answer is like, I got your request, wait for it. If you want to know what's going on, there's a link, you click in there, and you're going to go to the log page, which is just a plain text log which shows what's going on. But wait for it. And then it takes 30 minutes, 15 minutes, maybe an hour, and then it posts the next message, says, I'm done, I finished, that's the result of my work. So that's the communication, the chat bot we use.
There is this issue of establishing a conversation between two designated chatbots,
That's
or
right, yes.
individuals, or so on. How do you ensure this seems to be a really open room, chat room. If you really need to have a conversation established between two specific parties, so not to have other parties involved in that conversation, it's both basically the same as if you would create a connection between the two of them, so not using the chat room.
Well, in the chat room, we use, for example, on GitHub, we use this. You put the name of the person who you're talking to in front of the message. So we start.
I'm not talking about.
You're saying how they know where to talk to, how they know
security.
The security.
If I have three card payment modules and the people and the person there, and I give to one of the bots, I give them my card number. How do I know that? How can I ensure the fact that the other person will not steal my information?
Well, in this case, if we're talking about the card number, then probably you as a user should know that there's only one bot is talking to you in the chat room, or other bots you should just trust them. But this is just a corner case when giving like really sensitive information in the chat room, just a credit card. Because in most cases it's not that sensitive. In most cases we give information which you're still, let's say you would, so you're saying that if in the chat room we have two bots instead of one, yeah? And just one of them is supposed to get the information which I need and another one is not supposed to know about that, then you can encrypt that, for example, like you do in a public, in HTTPS, for example. So you encrypt, if we're talking about really something sensitive, then we can encrypt that information for the future. But basically, in most cases, the hub provides us the security, the authentication and authorization, because every person who is in the chat room already passed the authentication and authorization steps. So they were able to log in, to confirm their identity, to make sure that this is actually me talking, and this is actually the chat bot, which is ABC talking, not somebody else. So we trust the hub, that the hub actually authenticated all these participants of the room. And then we know that this is actually these guys are talking, not somebody else. But the question is how we can trust that there are many participants of the conversation. I don't have an answer. Maybe that's something for the future to think about. Some encryption or something, some kind of protection. But we don't have that sensitive information so far.
I recently heard an idea that this kind of architecture, it will be implemented with e-commerce. And for example, instead of microservice A, you have an e-commerce application, like a shop.
Yep.
And instead of microservice B, you have another shop. And as a user, you log into a chat and you type there what you want.
Yep.
I don't know.
Yeah, exactly.
Yeah.
That's how it's going to be. Yeah.
And apparently in China there is this kind of application and it's very, very popular.
You see,
yeah.
they stole my idea.
Definitely.
Yeah, definitely. That will be good for e-commerce. That definitely will work like that.
Yeah.
I just think that in general, the idea of web UI is going to slowly become less and less popular, because for us it's way easier to talk to somebody instead of clicking buttons and figuring out how to do that. It's just organically, more naturally, like it's better to open the web app or the mobile app, and let's say just like we're using this Siri or OK Google, whatever, and we just start talking, maybe even in natural language, and there is somebody on the other side who understands us, and instead of just finding out the right form and finding out the right link and clicking that link and then figuring out how to enter my credit card, it's easier for us to just drive and talk. So these chatbots is going to be the future. But this is talking about the consumer perspective. But from the architecture perspective, for us, the developers, I think that's how it's going to be technically. So we will have microservices who talk to each other through the hub. What kind of hub it's going to be, we don't know. Maybe the Facebook will provide us the functionality of speech recognition. So I will just design the microservice which is selling some stuff on Facebook. And I just advertise my page on Facebook and say like, hey, if you want to buy something from me, go on the Facebook and start talking to me. And then they go there and the Facebook will provide the functionality of people like saying something like, voice recognition, and it will be translated to the English text. And then I will be using some libraries for natural language processing. And that stuff will be converted to more formal information for me. And then my microservice will understand what this client is talking about, and I will be able to sell my stuff there, to sell or whatever, to do something. So all we need to do is, instead of making the website and promoting the website, we just promote our Facebook page and say, come to our Facebook page, click message me, and start talking to me. And you will get what you want from me as a shop, for example. I'm selling shoes, let's say. So you will be able to see everything to see there. That's what's going to be probably the future. Well, we're out of time. Thanks for coming.
Yeah, problem.
Thank you very much.